Okay, Algebra 2, this is Section 3.3 complex numbers. Um, I am going to add like 3 more questions or examples, I guess, to this note sheet, but we'll do those here in just a little bit. But complex numbers is kind of just off the topic of what we've been doing already. In section 3.4, I'll show you how complex numbers kind of relates back to quadratic functions because they're like super related to each other. But we'll wait and do that when I come back on section 3.4 because it's easier to explain to you in person. So complex numbers, basically the most important thing to remember is that an imaginary number or a complex number is the square root of a -1. Okay, when you're taking the square root, you're saying what two things can I multiply together, or what number can I multiply by itself to get this number that's inside of there. And there's no number that you can multiply by itself to get a negative number, because like a positive number times itself is going to be another positive number. A negative number times itself is going to be a positive number again. So there's no number that I can take times itself to get a negative number. That's why it's an imaginary number, okay? The square root of a -1 is imaginary. Now, if I square both sides of that, the square root and the square will cancel each other out to make just -1. So I squared is equal to -1. So these two things, make sure you remember. I is the square root of -1 and I squared is just -1. Okay? So let's go down here into example 1 and I'll show you how these break down. So the square root of -27, I'm going to break that down into, this is kind of like the square root of 27 times the square root of -1. If I put those back together, it makes -27. Okay, now the square root of -1 we said up here was I, so I'm just going to replace that with I, and then the square root of 27. Hey. Brad, you got to be quiet. I'm recording a video. 9 and 3 then is what 27 breaks down into. So we do the square root of 9 and the square root of 3. Sorry, my kids are loud. So that is 3 square roots of 3 times I. Or some people write that as 3I times the square root of 3. That's the way he will break down. So then square root of -1 becomes I, the square root of 27. We break down, and I think we've done it something like this before, where you have, 9 and 3. 9 is the number that goes inside the circle because you can take this perfect square root of 9, and that's 3 square roots of 3. Okay. The I usually write in the front instead of at the back, but it's not incorrect if you do it a different way. All right. B is going to be similar to that. So the square root of 216 times the square root of -1. Bradley, come get your kid. Shh, honey, you're okay. So the square root of -1 is I, and 216 will break down 216. Hey, come get her, please. Let's see, 216. I gotta think. 216. Let's do 36 is a big number. 36 and 6, I think, works. 36 and 6. So the square root of 36 is 6. The square root of 6 just stays on the inside. So I have 6 square roots of 6 times I, or 6I square root of 6. I always put that I in the center there. Okay? So there is that. Now, this guy right here, when you're taking -5I times 3I, just think of that as like 5x and 3x. So this becomes -15x squared, or I squared. Well, from up above here, we said that I squared was -1. So this is -15 times -1, which is +15. Okay, so that's how that one breaks down. This one over here, dealing with this guy, you have the square root of 6 times the square root of -1 is what this one becomes. And this guy over here is the square root of 15 times the square root of -1. Okay, so you basically have the square root of 6I times the square root of 15I, because those -1s are i's. Okay, and then we can multiply the square root of 6 and the square root of 15 together. That's the square root of 90, I think. And the i's will multiply to make I squared. Okay, the square root of 90 will break down into 9 and 10. the square root of 9, and the square root of 10. We get 3 square roots of 10. And this I squared, remember that I squared is -1. So we're basically taking this thing times -1 or putting a negative in the front of it. Just like that, okay? I guess this next question does kind of get into how parabolas end up, or how quadratic functions relate to complex numbers. When you're trying to solve for x squared here, and you have problems like this on your homework, I know, x squared plus 64 equals 0. When you're trying to solve that equation, we're going to move the 64 to the other side. So minus 64 minus 64. We have x squared equals -64. Okay, and when we take the square root of both sides to get rid of the square, we're left with x over here. But over here, this is like the square root of 64 times the square root of -1. Okay, and that -1 is I, and the square root of 64 comes out as 8. So the answer is 8i. But there's one thing that we're missing. Since we put the square root in there, I don't know if we've talked about this yet, but when we put a square root in, you have to put positive and negative. Because I don't know if that square root of 64 is a positive 8 or a -8. You put plus and minus, so that comes out as plus and minus 8i. So that's how he breaks down. Yeah, let me go ahead and just show you what this looks like. X squared plus 64 is a parabola that is like up here, and the y-intercept is at 64. Okay, he's an upward-facing parabola. And what you're doing by solving or setting that equal to x is you're basically trying to find the zeros, or where it crosses the x-axis. Well, when you have an imaginary in there, that means it crosses the x-axis right here at an imaginary place, meaning that it doesn't cross the x-axis anywhere. So when you're trying to solve and find those zeros algebraically, not by looking at the graph, when you're trying to find those zeros algebraically, you'll end up with an I in your equation. It's basically like this means no solutions, kind of. So that's kind of how those are related, all right? Let's go up here and let's do these problems up here. I think we've done, maybe we did these at the beginning of the year. I don't know if it was your class or the geometry class. But I separate these into pieces. So the square root of 50, the square root of x to the 3rd power, the square root of y to the 2nd power, the square root of z to the 5th power. And then I break you each one down individually. It's way easier to do it this way, okay? 50 you break down. So what goes into 50 that you can take the perfect square root of? And that is 25 and 2, okay? If you take the square root of 25, it's 5. If you take the square root of 2, it doesn't come out nicely. So it's 5 square roots of 2, okay? Now, x to the 3rd power, what goes into x to the 3rd that you can take the perfect square root of? And it's x to the 2nd power. And there's just one x. X squared and x make just x to the 3rd power, okay? The square root of x squared is x. The square root of x doesn't come out nicely, so you leave it, okay? Now, the square root of y squared, since this guy right here is an even number, I don't have to hang one of these off to the side like I did for x. This just pops straight out as y. Okay, the square root of y squared is y. And z, I'm going to have to do the same thing as I did with x. So I hang one z off the end here. Start with the one z over here, and z to the 4th power goes there. So when I take the square root of z to the 4th power, that's z squared, and square root of z just stays as square root of z. Now, I can shove it all back together. So 5 is on the outside, x is on the outside, y is on the outside, z to the 2nd power is on the outside. On the inside is 2xz. And that's what he looks like, okay? I just put all the outside pieces together of those 4 and then leave the inside pieces underneath it there, okay? Now, I to the 54th power, holy cow. When you're trying to simplify him or reduce him down, I to the 54th power, I don't know what that simplifies down to be, but I do know that I squared is -1, right? So let's see, 54 we can write as I squared to the, let's see, 27th power, because 2 times 27 will come back together and make 54, okay? Well, if I have it written like this, then I squared is -1. And if I take -1 times itself 27 times, that's an odd number, so it'll end up being just -1, okay? Now, I to the 77th, and that's it. That's all you have to do. I to the 77th power, Since that's an odd number, I'm going to write that as I to the 76th power times I to the first power. Okay, you always hang off one, like we did up here with the z's and the x's. You hang off one on the side. Okay, so let's deal with I to the 76th power. I know what I squared is, but I don't know what 76 is. So we write it as I squared, and 76 divided by 2 is 38. If I take 38 times 2, that's 76. Okay, and then I've got the other I hanging off the edge here. I to the first power hanging off the edge there. Well, this guy is negative 1 to the 38th power times I. If I take negative 1 times itself 38 times, it's just going to become a positive 1. And so I have positive 1 times I, which is just I. So I to the 77th becomes I to the 54th becomes negative 1. Okay, so you have to just kind of fiddle those out that way, and that's how those work. Okay, all right, example 4. You have an equation that looks like this. Let's see if that'll unblur here. And basically we are solving for x and we're solving for y, okay? So if you look at this left side piece and you look at this right side piece, okay? This 7 is the part that does not have an I attached to it, okay? So you look over here for the part that does not have an I attached to it, and that's the 3x minus 5, okay? If you look for the part that's imaginary over here, the 6, that has an I attached to it, and y minus 3 has an I attached to it over here, okay? So 7 is equal to 3x minus 5, and 6 is equal to y minus 3. You take the real parts and set them equal, and you take the imaginary parts and you set them equal, okay? So if I have 3x minus 5 equals 7, I'm going to add 5. Let me get a different color in here. Add 5, so 3x equals 12, and then divide by 3, and x is 4. Okay, so that's what x is. Y is a lot easier than that. You just add 3, and y is 9. And that's all. Okay, so set the real parts equal to the real parts, the imaginary parts equal to the imaginary parts. Okay, all right, on the back side, just a couple left. Adding and subtracting complex numbers. This right here is very, very similar to what you would do if this was an x here. If this was an x here. So 5 minus 7i plus 2 plus 4i. You're going to take the 5 and you're going to join it with the positive 2. 5 plus 2 makes 7. Negative 7i plus 4i is going to be negative 3i. And that's it. You join the 5 and the 2, and you join the negative 7 and the 4. Because you're just adding and subtracting. Now, when you're subtracting... I feel like I'm trying to quiet you guys as a class when I'm sitting here with my children. All right. So this part right here, when you're dealing with minus sign, I want you to do something just a little bit different, okay? Rewrite the equation when you drop the parentheses. 4 minus 8i, that is not going to change at all. You're just going to drop those parentheses down. But this negative, imagine that says a negative 1 there, and we're going to distribute that negative 1 through for both of those pieces, okay? So this 3 will become negative 3, and this negative 6i will become positive 6i, because minus a negative 6i, okay? All right, now I'm just going to join the like terms. So 4 and negative 3 is 1. Negative 8i and 6i is negative 2i, okay? All right, so 1 minus 2i, that's all. So when you're dealing with a negative, distribute the negative through for everything that's after the negative. Okay, not before, everything after the negative needs to become a different sign, right? And we're going to skip this part down here. We don't do example 7. You'll get to that next year. But multiplying complex numbers we are going to do. So, an AC circuit, the voltage V, current C, and impedance I are related by the formula. The voltage is equal to the current plus times the impedance. So this is the current, and this is the impedance, all right? 2 plus 4i, we're multiplying, because that's what it says, currents times impedance. 2 plus 4i times 9 minus 3i. Okay, and we're multiplying those together. So when we do this, we do FOIL. F-O-I-L. The first pieces are 2 and 9. 2 times 9 is 18. That's done. The outside pieces. Outside pieces are 2 and negative 3i. 2 times negative 3i is negative 6i. Okay, you treat these just like you do x's. All right. The inside, O is done. The inside pieces are 4i and 9. Okay, 4i times 9 is a positive 36i, and then I is done. And the last pieces are 4i and negative 3i, which makes negative 12i squared. Okay, negative 12i squared. So now the last piece is done. And then we need to combine like terms. Okay, one thing that you need to do before you combine like terms, right here, negative 12i squared. Okay, from the front side, remember that I squared is really like negative 1. Okay, so this says negative 12 times negative 1, which really is positive 12. Negative 12 times negative 1 is a positive 12. Okay, so now we have 18 plus 12 is 30, and then we combine negative 6i and 36i to make plus 30i. So 30 plus 30i is what we get for our final answer, right? So you treat it just like FOIL. You treat the i's like they are x's until you get to this step where I squared is negative 1. And then you multiply by a negative 1. And then you combine like terms, and then you're done. Okay? So we skip this bottom part. I don't put anything like that on your homework assignment. So homework assignment is the handout. On your handout, skills practice, do all of them. And practice, do just the evens. That's a lot of problems, but they go by really fast. Okay, we did like, I don't know how many problems, like a dozen. Okay, Brad, shut up. Okay, so there you go.
Very Ma.